Hello everybody. In this video we will talk about reaction of acyl chloride with Grignard reagent. So acyl chloride is when you have the COCl. So that's our acyl chloride. So just like we talked about before, when you have a carbonyl group, so let's say we have a carbonyl group CH3CO. So here you notice carbon is connected to oxygen, so it's going to have a delta positive charge, and this is going to have a delta negative charge. Okay, and then on top of that, if you add a chlorine to it, it will even pull more electron towards itself. So inductive effect of chlorine will pull more electron away from carbon, because chlorine is more electronegative, right? So as a result, your carbon will even more attracted towards an electrophile. So this is why acyl chloride are a lot more reactive than any other carboxylic acid derivatives. So let's draw the reactions here. So we know that our Grignard reagent, when you have CH3, CH2, MgBr, and when the questions are written like this, 1 dot, 2 dot, this means the reactions happens one after another. So it's a stepwise reaction. First you do this, and then you do the second step. It's not like a crock pot where you combine both of this together. If you do that, you're basically gonna kill your Grignard reagent by this acidic proton. You cannot have any acidic proton in your Grignard reagents. Okay, so this would react as if, so we know that this portions react as if CH3, CH2 minus. So the carbon atom that is connected to magnesium is going to have your nucleophile. It's going to have your negative charge. So this electron here, it's basically going to act as a nucleophile. So this would go and attack, obviously negative will attack the positive center. And when it does, you notice if these things get connected, the carbon atom will have 5 bonds. It cannot have 5 bonds. So obviously we have to move a pi bond towards oxygens. And we know oxygen had 2 lone pairs to begin with. Now we will have CS3, CO minus, and we got our CH2, CH3, and we have our chlorine. Okay, so CH2, CH3. So at this point, if you notice, our oxygens is negative. So pay attention to the carbon atom here. So this is, what kind of hybridization this is? This is sp3 hybridized. But if you compare this, here it is sp2. So sp3 hybridized carbon atom. So sp3 carbon atom. So this is our tetrahedral intermediate, right? So which is why we call it tetrahedral intermediate. Okay, so tetrahedral intermediate. So tetrahedral intermediate with O negative, right here, is unstable, and it wants to go back to sp2 hybridized carbon atom by removing a group. Again, if possible, that's the key idea, removing a group if possible. So in this case, what would happen is the O negative will bring back one of the lone pairs to the pi CO pi bond, and then so you got CO and CH2, CH3 plus Cl minus. So it kicked out the Cl minus group, to bring back the sp2 hybridized carbon atom. So this is back again sp2 hybridized. So this is sp2 and sp2. So it wants to be sp2 hybridized. Now, why didn't it remove the other group out? There are two other possibilities, CH3 minus or CH3CH2 minus. So in this case, the reason it doesn't do is, so we have Cl minus, or why it didn't do this, or why it didn't kick out these two. So these two are highly basic. So you cannot kick out a R minus group. So these are highly basic, R minus or H minus. You can't kick them out. You can't kick them out because these are highly basic. And how do we figure out why they're highly basic? Well, we can figure that out by looking at their conjugate acid. So conjugate acid of Cl minus is HCl. Conjugate acid of CH3 minus, I'm just using CH3 minus as an example. Both of these are almost equal, is HCl. What is the pKa of HCl? It's negative, right? pKa is, I think, -7. The idea is negative. pKa of CH4 is almost close to 60. So this is very, very weak acid. So this is very, very, very weak acid. When something is very, very weak acid, the corresponding base, which is this, is going to be very, very, very basic. So here it's going to be very, very, very basic. And basic means when something is very, very, very basic, it's going to be a very, very, very bad leaving group. All right, so that's the idea behind it. I'm going to delete these portions here so that we can continue with our mechanisms. So if you want any of these notes, you can pause the videos and collect all the notes and move on. Okay, so what functional group is this one here? So this one is a ketone right here. We just made a ketone. And we know that ketone is also reactive towards Grignard reagent from our earlier chapters. And this has delta positive, this has delta negative, and we still have plenty of CH3, CH2 MgBr. So if you notice, we have plenty of CH3, CH2 MgBr. Like try to imagine this. You're cooking crockpot reactions, right? So you have potatoes and carrots. So you have added salt. So everything is salted. Potatoes and carrots are salted. And then on top of that, later, 2 hours later, you add, let's say, what other vegetables? Broccolis to this soup. So when you add broccolis, the broccolis is also going to get salted because they're all being cooked in the same pot. So as soon as you make this, even if it wasn't in the beginning portion of the reactions, it will react with a second set of Grignard reagents, CH3, CH2, MgBr. MgBr, and what would happen? So this would react as if this is CH3, CH2 minus. So this would come and attack here, and that will push the pi electron towards oxygens because you want them to be octet. Carbon should always have 4 bonds, right? So let's do that. So this here would come and attack here, and that will push the pi electrons. So the intermediate that you will be making here is CH3, CO minus, CH2, CH3, CH2, CH3. Okay, so this is here. Now this is also a tetrahedral intermediate here. If you notice, the carbon atom at the center is still sp3. So now sp3 carbon atom with a O negative, can it kick anybody out here? Obviously, we cannot kick out any of these groups because these are very, very basic. So we cannot kick anybody out. So this, the intermediate that will exist as a final product until we neutralize it. So this is where the second reagent comes into play, the second step, where you neutralize the O negative ions. So you will neutralize it. In questions, you will see some questions will be written like this, H plus. Sometimes they will be written like H3O plus. Sometimes they just put H2SO4 to show you that you're adding acid. So again, it's just whatever the questions is written. So let's say when you neutralize with H plus, that's basically gonna neutralize OH right there, and then we got our CH2, CH3. So this is the main product that you should focus on, CH2, CH2, CH3. So that's our answers. So you started with an acyl chloride, and then you ended up with a tertiary alcohol. But this is where um, another reaction comes into play. This is for your informations. If you want to react with the okay, let's stop this video here.